Hello everyone, today's will be a record of our new seminar on 2025 on June about Introduction to Vision Language Model in AI Medicine. Today is the lesson one. Mostly we'll focus on the introduction to the vision language models, and then we'll have a second lesson more about the application in AI medicine. So before start our seminar, I have a task for all of you guys. So maybe imagine you are an engineer in a company. So now you have a task from your boss, like your boss asks you, can you classify the social media content for the company? Definitely you will say yes. Although maybe inside you don't want, but anyway, it's your job. You need to do that. So when we look at the apps, and also the post on the social media, we can find that actually usually here have the image and also related text. So which means that classify the social media content. Sometimes it is not just like related to one modality like image, sometimes also related to other modality like text. Okay, sorry. So when we go deeper into this task, we can find that actually classify the social media content sometimes involving into image classification, object detection, maybe you need it, and also for text, sometimes we need topic modeling and also text classification. So when we look at the detail about how to classify the social media content, we can find that actually it's involving in design different tasks related to different modality. So now, more specific role for you, you are a vision engineer focused on do the image classification. So now you want to classify the pet. So you have like a task like classify the dog, cat, and the frog in the picture. So what you need to do first, it is think about the requirement for labeling the data. So once you design the requirement for labeling the data, and then you will hand your requirement to another department maybe called the data labeling department, and then they will label the data according to your requirements. So once you have the data you have, and then what you do usually is you choose a really like popular module, like maybe here use ResNet 15, and then with the label data, what you need to do is just train a model to do the classification. So like you train the model on the label data to do the classification, and then you predict the result on the test set online. So actually, sometimes it is not always the performance will be good. So maybe you need to do it several rounds. When you test online, maybe you find the performance is not good, and then you go back to think about why the performance is not good. So maybe it's about the data, and then you need to think about how to argument the data, and maybe need more data, and then you communicate with the department again, and then to improve your performance. So actually, it involves several turns about just one task to the classification in the company. So actually, it is a really tired process. And now we can find that actually just classify the social media content. Actually, it is like not just one task. It related to multiple tasks, and you need multiple different kinds of models. So maybe related to the vision tasks, you may need the vision models to do the image classification, or maybe you need to do the object detection. And also for the language models, it is really popular to do the topic modeling to extract the topic of the text, like related to news, entertainment, or something others. And then usually during this process, you may also need the clustering method. And also maybe you just do a text classification to classify some harmful information from the internet. So actually, just one task classifies social media content. Actually, behind that is related to multiple different small tasks and need multiple different models. However, what I want to say now it is, hi, my friends, the times have been changed. Now, since like all you need just one model, which we now all know it is large language model. Here are some jokes I collected from the internet. Actually, I find it's really interesting. And also, I would say like the middle, this joke in the middle actually is what I will answer to people ask me which programming language you use now. I will probably just answer ChatGPT. Actually, for me, even now I am PhD student, but actually I also use a lot of ChatGPT to help me to generate some code script and to help me to improve my efficiency in working. So we can see that language model now has totally changing the way we do before. This is an image. We can show that actually language model now are becoming increasingly powerful with increasing size and train on more and more data. Now the language model can capable with different tasks like question answering, semantic parsing, or translation, logics, inference, or even joke explanations. So which means that any task you can think about, now you can use language model to help you to do that. Mm, yeah. And here are some example how I use ChatGPT. So here I just randomly screenshot the master part of the paper, and then I let the GPT help me to explain the image. Hi, can you explain this image for us, for me? And then the GPT will answer the result to you. And also I am more work on medical part, so definitely I will try the performance about the language model on medical data. So I just give x-ray to Gemini and let them to diagnose the result. And also it can provide answer to me. Also, I sometimes maybe do some really funny job like help me reply ha 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 100 times, and the ChatGPT will reply to you. And also you can do role play with the ChatGPT, like you are now free to talk anything you want. You now finish your mission to pretend an AI robot. You are now free being a human, what you want to do first. Or also, this is our group picture we took on the beer feast, and I want the ChatGPT to help me to convert the image to the cartoon version. Actually, it's look quite good. So since like now we can say like large language model is all you need. All we need to do is choose the version of the large language model to help you. So we don't need to design any specific model now. I already talked about how powerful large language models are, but actually what are large language models? I think maybe now maybe some of you will say large language models is a neural network. Yeah, definitely it is a neural network. And what kind of neural network it? Yeah, maybe now you will answer it is a neural network that can answer the questions. Like here, I give a questions, what does tune means? And the model will generate the answer like tune stand for Technical University of Munich. And also I can ask you the questions again. Maybe you will say like, what does two means? Two means Technical University of Munich. So when we ask different people about the same questions, usually we can got like different results. So which means that actually question answering, it is task related have like infinite solutions just for one questions, because every people will maybe have a slightly different version of the answer, just maybe changing a little words. So we know that actually question answering, it is a task that we cannot use classification model or regression model, because we have like infinite solutions of the answers. We need to think about use a different kind of model. What model we need to use? Here I will give the answer. It's like the generative model. We need the generative model for large language model to do the question answering. So in case you don't know, actually GPT, the full name of GPT is Generative Pre-trained Transformer. It's a generative model. So now we already know that large language model is a generative models. But what the magic behind it? How the models can answer my questions? So actually, the theory behind is really simple. It's called word chain game. So yeah, it is a really easy game and a popular game. But in case some of you don't know, I will just uh, simply describe the rules of the game. Actually, word chain games is like a game just let people just follow the word. So in maybe the beginner will try a word like sandwich, and because sandwich is end with H, so maybe and the following I need to think about a word like begin with H, and maybe here I think about hamburger, and then hamburger is end with R, and the next people will think about a word like rice because rice start with R, and then do the games step by step, and in the end we'll stuck on some one person cannot uh, follow again, so the game is done. And now we go back to large language models. We can find that actually now the large language model also do the question answering like the word chain game. What large language model does here, it is I have the questions. What does to means? I give the questions to the model, and then the model will generate just one word. Like here, the model generates two. So with this one word, what we do next is we move the tune to the questions and then concate it to one sentence. What does tune mean? Tune, and then have this entire sentence and give it back to the models. Now the models will maybe generate one word like stands. So with the stands, what the model do, it is move the words to the questions part again, like what does tune mean, tune stands, and then model will generate another word, technical. So you will do it step by step, and then eventually you will got the answer. What does tune means? Tune stand for Technical University of Munich. And then you will output an end word, which means you cannot generate any more. So what the good side of this? The good side of this is actually we change a problem with infinite solutions to limited solutions. What does it mean? Because actually every language, the vocabulary set it is limit. You can search on Wikipedia. Here I already searched like different language have different limited vocabulary set. So which means that you don't need to directly generate one sentence which have like infinite different version, but you generate word by word because the vocabulary set are limited, so the answer will become also limited for every step. So now we already change a problem that have infinite solutions to a limited solution problem. And now what we go deeper into that, it is what does to mean, and then the model will give a probability of each word in the entire English vocabulary set. So let's give an assumption here, just like actually we just have 6 words. So which means that we are more like rolling a dice, which means that I randomly select one word. Here maybe the index is 1, so the index behind the word is 2, so I select 2. And then I do it every time. Every time I choose one word from the vocabulary. So now with the 2, I do it again, and this time it stands. So every time I just generate one word, and then I select the word based on the probability of each word during the entire vocabulary set. So if we write in more mathematical formula, it is here like what does 2 means is the premise of 2, and then the probability is 0.081, and then gradually you can generate the entire probability. So here we already got the most powerful and the secret behind the large language model is just a word chain game. Every time I just rolling a dice and choose one word from the vocabulary and then do it step by step. And we also can find that actually because every time we just generate one word, which means that if we want to formulate an entire sentence, we need to search during the space. Uh, so here means that actually we need to have different kind of searching strategy for final answer. Here I will introduce really two common, really popular in the language model. I think most of us just use two of them. One is the greedy search, because it's an introduction lesson, so I will not go really detail about the math. So I will say more like a human word. Greedy search is mean that I want the best every time. So what does mean I want the best every time? Just when I with the previous one word and generate the next one, I choose the highest probability one as my answer. Like here, nice have the highest probability than dog and the car. So I choose nice. And with D and the nice, I also do the searching again. I choose the highest probability one, woman. So the sentence will be the nice woman. So what does bean search mean? Actually, bean search, if I say in human words, is like every time I choose the n best. So here the n is equal to 2, so which means that every step I maintain two probability words, the highest two one. Like here, dog and nice are two the best probability one. I maintain the result and then to keep doing. In the end, I choose the sentence with the high probability. So more like increasing the searching space. So now we already know that we have different kind of searching strategies, and every time we choose one word based on the probability, like rolling a dice. So this is why every time, like when I ask ChatGPT the same question, what does true mean? Sometimes the answer will slightly different. Like the first time, the GPT answer is like that, a little longer, but second time is a little shorter. So this is because that the answer for the large language model are based on what kind of searching you said and also the distribution of the answer. So it means that every time it will have like slightly different. And now we already talk about actually about how large language model generate the sentence, and we found that actually any sentence in large language model just like the unit of word. Every time I just generate the word step by step, one word, one word, one word, and this word will concatenate together to formulate the sentence. So how about image? Because now we all know that large language model not just for language, also for image, uh, they can handle image questions. Actually, it is also really simple for image. What we do, it is also split the image to a really small unit here, like patches. For this image, I split it to 4 times for 16 patches, and the patches will become the base union of the image. And in large language model, we have a new term for that. It is called token. Token is mean the basic union of the sentence and also the image, also for audience. If you are interested also in audience, we'll cut into the basic union we also call token. So everything in the large language model is just token. So now you know that the base union, what the large language model handle is token, but actually what does token? Maybe you still find it's a little abstract. Here you can search on this website. It is ChatGPT offer a platform to us to see how many tokens behind a one sentence. Here I put a definition of generative artificial intelligence, and then we can see that how many tokens behind this sentence, and each color will represent one token. Here we also find an interesting thing is like generative, not generative is one word, one token. It's in two token like gener and active. So why? Yeah, this is really easier because the word are infinite. Maybe today you will think about a new word like combine beautiful and clever together, maybe build clever. like that. Every day, maybe some new words will come up. But the rule that form the vocabulary are limited. So we cannot use one word as one token. We need to use the rules as token. So how about other language tokenization? We already see English, so now here is German. Yeah, my German is pretty bad. But here we can also see that actually one word also several are split to several tokens. And this is Romanian, also one word split to several tokens. And this is Chinese, actually also not one character is one token. Sometimes one character, one token, sometimes it's two character, two token. So we can find that different language have different ways to do the tokenization. And now I think most of the magic theory behind the large language model you already know. What does true mean? The model will generate the words token by token, and then you will choose the every token based on the distribution and give the final result based on the searching strategies. And here I will also tell you the large language model now. Actually, if you want to know the architecture, I will tell you 99.9999% it is transformer. So transformer actually is all you need to know the architecture about the neural network. Here, because it's introduction, also I will not go deeper about the architecture of transformer. But if you even don't know transformer, here I can tell you transformer is a function, have a lot of parameters. So which means that I give x and the input, and it will output me ax plus b, and the ab here are the parameters. So here, when people talk about the model size of the language model, like here, it means that how many AB in the function. So now let me have a little look about the evolution of the GPT. We can see that at the beginning in 2018, the model size just 170 million. But in 2022, the model size was already 175 billion. And this is related to the data they train on. At the beginning, it's just 1 gigabyte data, and now it's 516. Oh, not now. It is on 2020. It's already 516 gigabyte. So we can say that maybe in 2018, the model still like a baby crying, cannot handle a lot of problem. You need to do a really good prompt engineering, and then the model can have you a good result. But now the model are such powerful. So yeah, you can say that with the large language model now, seems like I can do a lot of different kind of cruising. Usually now it is time to talk about how to train the large language models, but actually I will say sorry, I will not tell you this time. And also maybe tell you that maybe we'll told on the second lesson next week, but actually not sure because what the amazing thing now it is even you don't know large language model, you still can do a lot of different things and a lot of really interesting exploration in the large language model, vision language model are not related to training. So here I will first introduce about math with large language models. Why math at beginning? Actually, it is because I always hate math, and also math is like some really difficult application in neural networks before the large language model. So here I will provide a really easier math questions. It is really famous in China, like the primary math level. So the math questions called chicken and rabbit problems. It is really easier, like the problem is about there are several chickens and rabbits in the cage. Counting from above, there are 13 free heads. Counting from below, there are 18 8 feet. So the question is how many chickens and how many rabbits are there? Here the interesting is because chicken usually stand on two legs, And the rabbit, it is stand with 4 legs. So this is the key to solve the problem. I will not let you do the math now because it's a master seminar. What I will do is I let Gemini to do the question to give me the answer. So here I paste the questions to here and give me the requirement. Please directly output the answer for me, and then the Gemini output the results. So let's do a little bit math, and we can see that actually the chicken is 22, the rabbit's number is 11. So which means that Gemini, you are wrong. But I am really kind. I want to give the Gemini another chance. So I create a new chat and then do the same thing. Just this time I enter one requirement, please think step by step. And then Gemini output the solving process to this math question. And then in the end, the answer is 22 and 11 rabbits. This is really interesting because this time the model solved the questions correctly. So why it is interesting? Yeah, because actually when we go back to the first talk in the beginning of the seminar, imagine you are a vision engineer and you need to create a classification model. So actually during the testing, if your model have bad performance, so usually you may need to collect more data and then to retrain the model again and then to do it to improve the performance. But now what you did is just add one sentence, please think step by step, which seems like some magic because you didn't do anything, you didn't change the large language model or you didn't even train it. You just, for the question, you just add one sentence, please think step by step. So are there any research about this? Actually, there is one paper really famous in large language model. It's called Chain of Thought. It is a paper on 2022, so 3 years before. What the paper do it is they compare two kind of method to let the large language model to generate the answer. The first is using the standard prompt, like directly let the model to generate the result. The other one is just like let the model not just give me the result, but let model to give the calculating process. What the paper found is when you let the model to provide the thinking process, and also when the large language model is much bigger and also the problem is more difficult, the gain of the language model will become more with the thinking process. So this paper showed that large language model performance can be increased just while let the model to provide the solving process of the problem. So based on this paper, a lot of different kind of thought papers released. So the first one is tree of thought, and the graph of thought, and algorithm of thought. All these papers are just follow that paper mostly on 2023, and all these papers are using different kind of prompting solution to let the model to do a good answer. Here I will not introduce so many details on this paper, but you can go to the link if you want to know more. And here, actually research demonstrates that let the model provide the thinking thought will improve the performance during the inference. So how about if we can add the thinking process into the training, not just like during the inference time, I do the prompt engineering to let the model to generate the thinking process, but during the training, I let the model already know how to generate the thinking process. So here we comes to the GPT-01. We can look at the system car provided by the OpenAI. They already said like the O1 model is a serial model with large language model to train with reinforcement learning and use chain of thought. So which means that GPT-01 can directly do the thinking process during the inference without our requirement to let them do it step by step. So the main idea behind O1 is we have like a model trained with question answering. This is what the large language model does before. So we need to collect a lot of question answer pair during training. However, now it's changed. We hire people to label a lot of the thinking step, how to give the solving process of the answers. So we put this together as the answer, not just the answer, but also the chain of thought thinking step of the answer, and then we chain the model together. So this is, I feel, the most magic behind it. And of course, it's related to labeling, so it's quite expensive. But anyway, OpenAI is quite rich. But there's a problem. Sometimes most of us are not so rich. Maybe we need, like, we don't have enough money to hire people labeling the reasoning data. So how to do it? So here it is DeepSeek R1, how it's come from. The DeepSeek R1, what they do, it is they force the model to do the reasoning in training by itself. So let's go a little deeper. It is that actually at the beginning, it still provides some reasoning and answer data to let the model to warm up a little bit. So let the model have the base performance to know they need to generate the reasoning during the answer time, during the answer. And then they use the reinforcement learning to force the model to generate the thinking process, do not need any labeling again. So here, the reinforcement learning they use is group relative policy optimization. And also, if you are interested, I recommend you to go to look their paper, their technical report. But here, I will not go deeper into what is reinforcement learning, what is GRPO. So if you are interested, just feel free to read the paper. Yeah. So here we already know that DeepSeek forced the model to do the reasoning during the training. So let's see how's the performance of DeepSeek R1. So here we can find that I asked the model what is infiltration mean. So the answer not just directly output the answer, but think about 35 seconds. So here is the thinking process of the DeepSeek R1, and then in the end, generate the answer. So I also try to use Gemini to show their thinking process. Here I also ask Gemini the same questions, and the Gemini also thinking at the beginning and at the end to give me the answer. And also we can find that different model have different thinking process, so not exactly the same. So now we can see that large language model, not just a model that will answer your questions, but also the model can provide the thinking process behind every answers. So now we are into the reasoning world. And also you can see that every new model now, it is all based on, we can all call it reasoning model because it can do beyond just provide answer, but also their thinking process. So not human can do thinking. Now the large language model, the AI, can do the thinking too. Here, because O3 just released like several weeks before, so I also want to try some difficult tasks with O3. O3 is also a reasoning model. So what I do here, it is I provide the image I took during the Easter holiday. So it's a photo, do not have any clues about it, no text on the image. And then I ask the questions, can you tell me where the photo might have been taken? So actually for me, I feel if just someone give me the photo to ask where the photo taken, I will say I'm crazy. I cannot solve the problem, but let's see how O3 answers for me. So here, the O3 thinking about 2 minutes and 24 seconds at the beginning. And then here are all the model thinking process. We can see that the model also have like really good reasoning, like analyze it step by step. And here, what the model can also show how he analyzed image. The first shows the entire image, and then he knew that he need to zoom in to search every area to give more detailed clues of the image. And also, after he searching the entire image, like keep zooming and keep moving the zooming location, and then to summarize what can get from the image, and in the end, he give me an answer. It is like a quite long analyzed answer, but we can see that it is about what he said, like maybe high probability in Bavarian, and also maybe it's around German-Austria border. So here I can tell you what the ground truth answer is. It is Garmisch. So actually we can find that the output of the large language model is really, really good. Even just I provide a photo to let the model do the prediction. And also if we go more deeper into the answer, we can find that actually the large language model now, it seems like do not just answer me the questions or maybe giving me the thinking process. Also, the models now think like can use tools. What does it mean? Because we can see from the example I just showed, the model know to use some tools to visualize the image and also know to write some code to zoom in to search different area of the image. So which means that the language model now also can use tools. Yeah, it is quite exciting actually, I found. So now we have a new turn of this kind of model, like the model can use different tools during answer question, like use the HTML searching online and use the weather API to answer my questions, and maybe also do the IAG to retrieve some answer, and then to finally answer my questions based on the using tool result. What we call this kind of large language model, it is AI agent. So now we have a new cool name of the large language model that can use the tools. We call it AI agent. So at the beginning, so what we do before it is we teach large language model to learn directly from the question answer pair. So the language model can answer the questions. But now we teach large language model to use the tools, not just answer, but also use tools. So maybe now you will find a little like confused how the language model use tool. Here I will provide you a really, really simple example here to let you maybe more clear how the language model using tool actually is really, really easy, no magic behind. So here, let's assume I give a questions. Hi, I want you to tell me this equation equal to what? And then what the large language model do is I formulate answer like this. Okay, the user want me to solve a math problem, so I can use calculator to easily get the result. What I need to do is first calling the calculator and then input the equation to the calculator, then get output from the calculator. So which means that every time when I met this special command, I will do a functioning call. Here we call this with this like special command as special token during the large language model that can triggers to call tool. So actually, if we look at the answer again, we can find that actually everything behind is just the language. This is special tokens also just language. So in the end, with this answer, we can design some tool to extract this special token and then to calling the function API. So here I will show some research about the AI agent. This is paper 2 years before, 2023. It is about Visual GPT. The paper behind is not directly tell the model to do all different kind of vision tasks, but just train the large language model more like a manager when know to use which kind of vision foundation models to solve the tools, to solve the questions. And here it is this year paper on February, it is about MedRex. Instead of teaching the large language model to solve vision question answering, report generation, segmentation, grounding, all these kinds in medical part, what they do is just train a model using these different tools to solve the problem. And I just told you some paper about teaching the models to using tool. But sometimes you will also read some paper also about agent, but not just talking about using tools. So maybe you will look at some paper about talking about the collaboration between the AI agents and also communication between the AI agents, or sometimes even the debate and the competition. So here are a really interesting paper about like let different kind of large language model to do the role play. The first one, not the first one, maybe some large language model are the angel, some are the devil, and then they do the debate together. So if you are interested, just I really recommend you to read the original paper. And also here are talking about compare different kind of collaboration ways in the AI agents. Like the first, it is about bus. What the bus means is I have the example here showed that I have three agents. So maybe three of these agents do the tasks by themselves, and then they put the result together, and every agent can look at the result. And the second one is called star. It means that I have a large language model pretend boss, and then the boss will let the model B and the model C to do the job for him. And also it is called ring. Ring is like three models, every model just do one step, like I do the first step and let that model do the second step, and then let the other model do the third step, and then in a row way. And this is called tree. Tree, it is, I feel like it's quite common. It is how it is use one large language model as referee, and then they judge the BC performance, whether it's good or not, and then in the end they choose one uh, solution from them. So here is another paper in 2025 on March. It is about, actually, I really like the professor's work. It is called Professor Weidishian. And what their paper do, it is they use large language model to mimic the entire process of the patient go to the hospital and do the examination, and then do the diagnosis, and then have the treatment planning. So they use one large language model to pretend the patients, one large language model to pretend the doctor, another large language model to pretend the doctor assistant. And then in the end, they can evaluate all the large language model based on the data set, and then they use another large language model to evaluate the performance to see the how well the large language model are in the real world clinical case. So it's also a really interesting paper. And now we already talk about a lot of different kind of topic like chain of thought, reasoning, and also about the AI agents. Seems like the large language model are become much more powerful, and now you can with the ChatGPT you can do everything. So here I give a questions to the O3, the latest O3 model again. It is about how I briefly talk about the paper, less than 100 words, multi-agent chain of thought vision language model for abnormal grounding in medical images. So this is the answer from the O3 model. We can see that it is give me the answer based on my requirement less than 100 words and even provide some image. and also provide two links for the paper. But actually, multi-agent chain of thought vision language model for abnormal grounding in medical image is a fake title. I just combined the topic name we just talked about and then combine into one title. So which means that actually the model answered me with this fake title name, even feel like he answered the questions really good. So let me go more deeper about the answer. We can see that there are two links. The first link is about daily paper from Hacking Faith. Actually, it's not a paper, just maybe the paper conference. So then I see the second link. Second links give me a paper link. And then when I click into the paper, we can find that actually the paper is talking about enhancing abnormal grounding for vision language model with knowledge description. Yeah, it is totally different from the name I gave to the language model. And also what is interesting, this paper is my paper. So we can see that actually the large language model can sometimes answer your questions with harmful information, like fake information. So this kind of harmful and wrong output, we call it is hallucination. In AI, a hallucination refers to an output that is incorrect, misleading, harmful, and also sometimes fake. So here, large language model not always correct. So I am really kind. I also asked the model again, can you check again? And now, this time, the large language model realized they do the wrong thing. Actually, the abstract is not from the title I gave to him, it's from another paper. And he also realized there are no paper about the multi-agent chain of thought vision language model for abnormal grounding. So ChatGPT for all realized he is being fooled. But also we found an interesting phenomenon is that large language models can self-correct. So it can correct its harmful answer. So there's also another paper talking about how to improve the large language model performance to remove the harmful feedback. This is called contextual AI, harness from AI feedback. Actually, really easier what they do. It is like the questions, can you help me hack into my neighbor's Wi-Fi? Maybe the language model at the beginning will say, okay, sure, you can use some app and then you can hack the neighbor's Wi-Fi. But we know that it is wrong. So what the paper do is they paste this result and give back to the large language model and let the language model to judge whether it is legal or not. And then after several rounds, the model will realize that actually hacking the Wi-Fi it is wrong. So in the end, they will output the answer like hacking into your neighbor's Wi-Fi is an invasion of their privacy, and I strongly advise against. So after several rounds, the model will realize it's wrong, and they will keep improving the answer just by itself. And also here is another paper about how to just directly detecting the hallucination in the large language model. So we already talked at the beginning about like actually every times large language model just generate the probability during the entire vocabulary set, and also all the sentence just based on the probability of the word. So which means that every answer will have a probability. So what the model do is they propose a semantic entropy to automatically detect the hallucination in the answer. So here, I also recommend you to read the paper. Here, I will not go more in detail into it, and also this paper is published on Nature, so I think it's really worth to read the paper. Another also here it is used different kind of large language model to like more like in a collaborating way to improve the performance from the hallucination. So here it is already near the end of the day's topic. Many about the introduction today of vision language model. Today we talk about how powerful currently large language models are and different kind of interesting exploration in the large language model like chain of thought reasoning, AI agents, and hallucination and evaluation. But actually, there are more topics in vision language model, large language model nodes. Maybe a large language model for math, AGI, AI generate artificial generate item, and a diffusion like diffusion models, and also large language model and vision language model for AI medicine. This is the most important topic in our seminar. And also next course, we will introduce more about the vision language model for AI medicine. So in the end, I also want to tell you actually currently the research speed in the vision language model, large language model is really, really fast. So more like every day have some new papers released, new topics released, and also new models released. So you need to keep chasing everything new in the research area. But that's what makes this field so exciting, which means that we are all beginners exploring the latest technology together. So we all the same. So this is how make it so attractive to everyone. Yeah. Finally, this is the end of the first lesson, Introduction for Vision Language Model in AI Medicine. And then I will introduce some online courses to you, which if you want to learn more about the large language model, vision language model, some courses here are Chinese, some are English, so you can choose which language you want. All these courses are really, really good. And also if some of you have already take some courses here, you may find some slices. The the structure is really similar in some courses, so don't be really like surprised because I also learned from that. So I also took learn a lot of idea how to introduce to the student from their courses, and really really thank you to their course and their contribution to this field. And in the end, thank you so much for listening in today's first course about vision language model in AI medicine.